Okay, in lesson 19, we are combining surface area and volume, and the goal is to be able to determine when you need each one. So on the first one, it says a box needs to be painted. How many square inches need to be painted to cover the entire surface of the box? So I have to think to myself, am I figuring out what's inside it or what it takes to cover the outside? And in this case, it's what it takes to cover the outside. So that means I want to find surface area. On the next one, a juice box is 4 inches tall, 1 inch wide, and 2 inches long. How much juice fits inside the box? So I need to think to myself, are they asking what's inside, or are they asking what it takes to make the box itself? They're asking me how much fits inside. So that's volume. Okay, go ahead and fill in the Venn diagram down below. Pause the video until you have it all written down, and then go ahead and go to the next page. Okay, on example 1, Vincent put logs in the shape of a rectangular prism outside his house. However, it is supposed to snow, and Vincent wants to buy a cover so the logs will still dry. If the pile of logs creates a rectangular prism with these measurements, 33 centimeters long, 12 centimeters wide, and 48 centimeters high, what is the minimum amount of material needed to cover the pile of logs? So sometimes it is helpful to draw yourself a picture. And in this one, it is 33 centimeters long, 12 centimeters wide, and 48 centimeters high. Now it tells me I need to cover this. So if I'm figuring out how much goes around it, I am figuring out surface area. I am not figuring out the volume. Okay? So I want to figure out, first I'm going to think about the front side. Okay? Okay. So that front side is 33 by 48. So I will need the front and the back. So surface area 2 times, and the front and the back is going to be 33 times 48. Now the side, so if I think about this side right here, okay, I'm going to have both sides, and those are going to be 12 times 48. Now the top. Now remember, I'm covering a pile of logs. So I do need the top, but what I do not need is the bottom. So I only need the top. Don't need a bottom. So plus the dimensions of the top are 33 by 12. It's 33 times 12. Okay, so now I'm going to go through and do my multiplication inside the parentheses. So I've got 2 times, then I use my calculator, 33 times 48, and I get 1,584 plus 2 times 12 times 48 is 576. And then for the top, 33 times 12 . All right, now I'm going to take care of my multiplication. So I have 2 times 1,584, and I get 3,000 168. And then I've got 2 times 576. 1,152 plus the 396 for the top. Remember, we're not multiplying that by 2 because we don't need a bottom. So now we're going to add those numbers together. When we do that, our surface area of the covering is 4,716 centimeters squared. Okay, let's move to the one underneath this. Okay, exercise 1. Quincy's Place wants to add a pool to the neighborhood. When determining the budget, Quincy Place determined that it would also be able to install a baby pool that required less than 15 cubic feet of water. Quincy's Place has 3 different models of a baby pool to choose from. So we have our 3 choices. And then we have to figure out which one's the best choice for the baby pool and why the others aren't. So when I look at this, I have to think to myself, am I finding volume or am I finding surface area? Well, they said it has to be less than 15 cubic feet of water. So if it's cubic feet, that must mean it's volume. So volume, length times width times height. So I go to the first one, 5 times 5 times 1, 25 feet cubed. The next one is 4 times 3 times 1. So 4 times 3 is 12 times 1 is 12. So 12 cubic feet. And choice 3, 4 times 2 times 2. So 4 times 2 is 8, times 2 is 16 cubic feet. So it says which of these is best for the baby pool? Well, it has to be less than 15 cubic feet of water. So choice 2. And why are the others not good choices? Okay. Choice 2, because it is the only one less than 15 cubic feet. Okay, on this page we're going to skip over number 2 and go straight to number 3. And gift has the dimensions of 50 centimeters by 35 centimeters by 5. You have wrapping paper with the dimensions of 75 by 60 centimeters. Do you have enough wrapping paper to wrap the gift? Why or why not? So if I'm covering something, is that surface area or is that volume? It's going to be surface area. Surface area okay. If you need to, draw yourself a box and label your measurements to help you. So 2 times, I have 50 by 5 plus 2 times 35 by 5. And then the top and bottom, 2 times 50 times 35. So that surface area, 2 times 250 plus 2 times 35 times 5, 175 plus 2 times 50 times 35. So now I'm going to take care of my multiplication. So 2 times 250 is 500. 2 times 175 is 350. 2 times 1,750 is 3,500. And when I add all those up, I get 4,350 centimeters squared. Okay. Now I go to the wrapping paper, and it is 75 centimeters by 60 centimeters. So now I'm finding the area of the wrapping paper. So it's a rectangle, base times height, so 75 times 60. And I get 4,500 centimeters squared. So then I have to ask myself, do I have enough wrapping paper? Is this number larger than what I need? And the answer to that question is yes, I have enough. Okay, question 4. Tony bought a flat rate box from the post office to send a gift to his mother for Mother's Day. The dimensions of the medium size box are 14 inches by 12 inches by 3 5/10 inches. What is the volume of the largest gift he can send his mother? So it tells me volume. Length times width times height. So volume equals 14 times 12 times 3 5/10. So I grab my calculator, multiply those together, and I get 588 inches cubed. So the gift must be 588 cubic inches or less. Go ahead and go to the next page. Number 5, a cereal company wants to change the shape of its cereal box in order to attract the attention of shoppers. The original cereal box has dimensions of 8 inches by 3 inches by 11 inches. And the new box the company is thinking would have dimensions of 10 by 10 by 3. Which box holds more cereal? So holding more, that's volume. So the volume of the first one is 8 times 3 times 11. And so when I multiply those together, 264 inches cubed. The second one, 10 times 10 times 3, that gives me 300. So 300 inches cubed. So this one holds more. Now the second part of the question here says which box requires more material to make. So that's my surface area. So on this one, 2 times 8 times 3, 2 times 8 times 11, 2 times 3 times 11. So at this point, we're going to make this, I'm going to do all the multiplication. And so this is 48 and 176 and 66, and when I add those together, 290 inches squared. Now the second box, so its surface area, I have 2 times 10 times 3 plus 2 times 10 times 3 plus 2 times 10 times 10. And so we end up with 60 plus 60 plus 200, so that is 320 inches squared. So it takes more material. Now remember, on problems like those two, if you need to, draw yourself the box and label your dimensions. Okay, those are always skills for you to use whenever you are trying to decide what to do and what numbers to use. Okay, on number 6. Cinema Theaters has created a new popcorn box in the shape of a rectangular prism. The new popcorn box has a length of 6 inches, a width of 3 5/10, and a height of 3 5/10, but does not include a lid. How much material is needed to create the box? So that's my surface area. So 2 times the front and the back are going to be the same, and they are 6 by 3 5/10. So that's this right here, and then that back side there. Now we are finding the sides 2 times, and it is 3 5/10 by 3 5/10. Now we don't have a top, but we do have a bottom, and so I'm not going to be multiplying it by 2 because I only have one of those. And the area of the bottom is 6 by 3 5/10. Okay, so now I'm going to use my calculator. I'm going to do my multiplication. So I have 2 times 6 times 3 5/10. So 42 plus, then I've got 2 times 3 5/10 times 3 5/10, 24 5/10, and then 6 times 3 5/10 is 21. So I add those together, and I get 87 5/10 inches squared is how much material, how much cardboard they're going to need in order to make that box. Now the volume says how much popcorn does the box hold, so that's how much fits inside it. So the volume equals the length times the width times the height, so 6 times 3 5/10 times 3 5/10. So I go to my calculator, and I get 73 5/10 inches cubed, because remember, volume is cubed. Okay, go ahead and turn to the problem set. Okay, on this problem set, I would like you to cross out problems 2 and problem 7. So problem 7's on the next page. So cross out problem number 7. Go ahead and get started.